Okay, this might take a minute, but we'll get this finished. So what we're going to do is we're going to do a rate law for this equation right here. And we're doing it, sorry about that, it's smudged. It's the curse of being a left-hander. We're doing it off of this information. And remember what I said, that you need to determine an actual rate law by actually doing the experiment in the lab. So what I have here is 2A plus B yields, or plus 2C yields 3X. This is a pretty unlikely reaction just because, when you have three things trying to collide, that's bad. And then you got like two of these and two of these and one of those. And what are the odds they're going to have the proper energy and orientation? But apparently it does work to some degree because it has a rate here of production of X, okay? And so what we've done is we've adjusted A and left B and C the same. We've adjusted B and left A and C the same, and adjusted C and left A and B the same in these different trials. So I need to determine by looking at the change in concentration and the change in rate, what order, what effect each reactant has on the reaction. Now, pause the video and make a copy of this table, and your life's going to be about 20 times easier. And don't roll your eyes and act like it's some big deal, because I did it and you can do it too. Okay. So now that you have your copy, let's mark it up together. Okay, so the first thing that we're going to do is we're going to look at A. So usually start out just looking simple. And so I look at trial 1 and trial 2, and I see that I double the concentration of A. And then I look over at B, stays the same, C stays the same, so that's it. So if I want to figure out what the effect of changing the concentration of A is, and that's what I need to do in order to write this rate law, I just need to compare trial 1 and trial 2, because A changes, B doesn't, and C doesn't. Okay, so what I do is I like to mark it up a little bit. So here and then here. And so I double the rate, I double the concentration here. So we'll put that as 2, okay, X, and then we'll get the rate here, and the rate goes from 3 times 10 to the negative 4th to 1.2 times 10 to the negative 3. And so I can do that math in my head, but just be careful. So I'm going to plug it into my calculator and say it as I go. So you take the larger number over the smaller number, okay? So that would be 0.0012. Like that, okay? Divided by, now here's where people make a mistake. It's 3 times 10 to the negative 4th. So 0.0003, okay? And then my answer is 4. So, whoops, I didn't mean 2x. I meant 2 to the x power. Sorry. So, I'm not going to restart this video. I'm already like 4 minutes in and I'm marked on this. So, I didn't mean 2x. I meant 2 to the x power. So, what time 2 to what power is 4? So that 2 to the second power. So, 2 to the second power equals 4. That's a true statement. And so what that tells us is that A is a second order reactant, okay? And so rate equals K and then A squared, okay? So you got there, rate equals K A squared, okay? Now, I'm looking at B. So I would like to show you here, you can't use 2 and 3, okay? It seems like, oh, that goes, that is 3 times, that doesn't change, but look, that does change. So that's why you can't use 2 and 3 for B, because you wouldn't know whether the effect on the reaction would come from A or it would come from B. So I'm going to have to figure out a little more here. So I look at, 1 and 3 look pretty good, okay? Because when you look at 1, A is 0.1 and 3, A is 0.1, so that's good. B, 0.1 to 0.3, that makes it go 3 times as fast. And then C, boom, boom, or doesn't make it 3 times fast, just, 3 times. It's 3 times. We don't know what happens yet. I'm not trying to predict the future, and actually I know what happens. Okay, so C doesn't change, A doesn't change, B changes, so let's figure out with B. So we're tripling it, so 3 to the x power equals, well now, this one's going to be easy, because, look, 1 and 3, it doesn't change, it's the same number. So any number divided by itself is 1. So 3 to what power is 1? 3 to the 0 power is 1. And I'll show you that here in the calculator. 3 caret 0. See there? It equals, answer's 1. Okay. So B is a 0 power. See where A was a square power, a 2 power. It's second order. B is a 0 order. So it doesn't make our rate law. That's, it just doesn't have any effect. Doesn't matter. As long as we have it there, we need it to do the reaction, but the concentration doesn't make it go any faster or slower. So, okay, it just doesn't go in the rate law. It does not affect how fast the reaction goes. So now I'm looking at C, and with C, I've got 2 and 4, because 2, your A is 0.2, and it doesn't matter that it's not 0.1, that's fine. A is 0.2, and it's 0.2 and 4, so A does not change, and then B is 0.1, stays 0.1 for the fourth one, so it does not change. And then C is 0.1 to 0.2, so it doubles. Now, side note, after you have discovered a reactant is 0 order, sometimes there won't be one where this one doesn't change. In this case, there is. They were kind of kind to us. But once you figure out it's 0 order, it doesn't matter if this one doesn't change. Once you figure out this is 0 order, you can kind of do this to it, because you don't need to mess with it anymore, okay? But we do need to figure out what C's doing there, and we're going to use 2 and 4, okay? So this goes double, so it's going to be 2 to the x power. God, I can't believe I said 2x earlier. I don't know what I was thinking. I was listening to my kids or my dog or something. And then it goes 3 times 10 to the 4th, and then 2.4 times 10 to the 3, okay? So I'm going to go 2.4 times 10 caret negative 3 divided by parentheses 3 times 10 caret negative 4, boom, 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 8. 2. Oh, no, that's wrong. I wrote that down wrong. So you see here, for 2, it's 1.2 times 10 to the 3. And here, it's 2.4 times 10 to the negative 3. And so, I have to, and this is why you got to pay attention to these, because I tried to use 3, and I was like, that doesn't seem right. Okay, when I got the answer, it didn't work out to a whole number, and I was like, that does not look right to me. And so, going back, it is 2.4 times 10 caret negative 3 divided by parentheses 1.2 times 10 caret negative 3, boom, boom, and that gives me a 2, and that's kind of what I knew the answer was going to be anyway. But when you see here, you take that divided by that, you take the bigger divided by the smaller, and you get 2. 2 raised to what power is 2? 1, and so it's C, okay? And so now that is the skeleton for my rate law. Now, the next thing we need to figure out, this is an overall third order reaction because you've got a 2, and then you can put a 1 up there if you want, but the 1 is understood. If it's a 0, it doesn't even go in the reaction. So it's 2 plus 1. This is a third order overall reaction. And so the units for K, if you go back to the previous video, if it's third order, it's going to be 1 over seconds times molarity squared to cross off 2 of those molarities. We kind of got 2 extra molarities. But before we put a unit on K, we need to figure out what our actual digits are, and I've made a hash of this up to this point, but I think we can make it. And so you just take one of the trials, write down K, because we don't know what K is, but when you look at the trial, you know what A is, and A is 0.1, and C is 0.1, so it's 0.1 squared times 0.1 equals 3 times 10 to the negative 4th. Divide both sides by 0.1 squared times 0.10. Okay. And so, doing that, I've got K isolated, and all I got to do is solve that. So, I'm going to go 3 times 10 caret negative 4 divided by, I'm going to do this in 2 steps, divided by parentheses 0.10 squared. So that's 0.03 divided by 0.1, 0.3. Okay. So K equals 0.3, and the unit for K, which they will ask for since this is a third order reaction, is 0.3, 1 over seconds times molarity squared. You can just put that there like that. And so that's going to be our K right there. And then you can then plug in any concentration you want for A and C. A lot of times they'll have like a 5th trial here where it'll give you concentrations and it'll have a question mark right here. But for this one, they just want the rate law. And so what you're doing is rate equals 0.3 1 over seconds times molarity squared A squared C. And that is a rate law, and it only took me 15 minutes to do.